nothing but Q. Q value we have to calculate. So we have to calculate the kVA rating of transformer. Means Q value we have to calculate. Q value we have to calculate using the given data. We shall study that one by one. Okay. Am I audible properly? Is it audible?
Yes, sir.
Okay, that's fine. So problem is like this. I will solve one problem perfectly. You'll come to know what are the how to solve the problem. Okay, in machine design, this problem will make a much role. Problem will take the much role here. Okay, we shall discuss that. Okay, is it visible? Problem. I think problem is visible to you, right? Okay. So what we have to calculate from this data is that we have to calculate the kVA rating of transformer. What we have to calculate? We have to calculate the kVA rating of transformer. So in this data, what are the given data here? What are the data is given here? So it is the three phase. It is the three phase oil cooled core type transformer. So whatever transformer we are using, it is the oil cooled. Don't bother about it. As following between before going to this problem, you have to understand two things here. One thing is that you have to understand the core dimensions. So in one video I have posted, in one video I have explained that what are the core dimensions we have explained. What are the dimensions of core? HW, WW, height of window, height of core, and distance between the core is capital D, and diameter of circumscribing circle is small d. So you will get the perfection. You will get the perfection. So better. So you go through the dimensions, that video one more time. Okay, it will be useful to you. So in the meantime, just roughly I will explain again one more time. Don't bother about it. So distance between core center we have given, height of window is given, and diameter of circumscribing circle is given. Diameter of circumscribing circle is given, and flux density is given, current density and window space factor are given, and core area factor. This much value given, we have to calculate kVA rating of transformer. Let us see. So what are the given data? So given, what are things they have given? So it is a three-phase transformer. So it is a three-phase transformer. We have to use the three-phase equation. What is that three-phase equation? Three-phase equation is equal to Q is equal to 3.33 frequency flux and AW KW delta 10 to the power of minus 3. So that equation we have to use. Distance between core center. What is the meaning of this one? Distance between core center is that, so it is the core. So better you write all the things in your notebook. It is the core. In dimensions of core, I have explained this one. So it is the core of transformer. So if you see in a front side, so it is a front side. It is the front view we are seeing here. These are the windings we are placing on the core on each side, primary and secondary like this. And if you see the front, from the front view, if you see, it looks like this. It looks like this. It looks like this. If you see the front view, so it's just like, it looks like a square and windings are looks like this. Understanding this one? So if you see front view, so it is the core, and windings are looking like this from the front view, sorry, on the from the top view, from the top view. So now it is called as distance between these two core. It is the center core. It is the center core. Distance between two center is capital D. Distance between two core, that's they are given. Distance between the core center is 0.2 centimeter. Means what they have given? They have given the capital D. They have given the capital D. Next, what they have given? Diameter of circumscribing circle is 0.14 meter. Diameter of circumscribing circle. What is meaning of circumscribing circle? It is called as circumscribing circle. So it looks like a circle, correct? So it is the core, and surrounding to that, it is the winding. If you see from top view, it just looks like a circle. It's called as circumscribing circle. It looks like a circumscribing circle. If it is a circle, definitely there is a, we can see this is the diameter. It is the diameter. So it is named as small d. We are naming it as a small d. What is a small d? Small d is the diameter of circumscribing circle. That value is given. It is 0.14 meter. Then height of window is given. Height of window is given this much. This is the height of window HW is given. So flux density is equal to Bm. Then current density is given. It is delta. So current density is 2.5 ampere per millimeter square. But while substituting in problem, but we have to convert the data. We have to convert the data like this. Okay. Then so they will give you. So Windows space factor, nothing but what? It is the KW, Windows space factor. Windows space area by where is it of given 0.56. Then it is the code to start to calculate the you have to calculate the kV rating understood. First they have KW delta frequency. Do about it. Frequency, yes, frequency value is given 50 hertz. Flux is given, flux is not given. AW is given, no, AW is also not given. KW is given, yes. Current density given. So first what you have to calculate? These things we have to understand. Correct? So we can write this flux like this also, right? 3.33 frequency that it is breaking, voice is breaking. Is it breaking again? What about now? In place of flux, even I can write Bm into AI into AW, KW delta 10 to the power of minus is given, Bm is given, this data is not given. AI, so first we have to calculate this AI and AW for a calculation of KVA rating. From all these given data, first we have to calculate the AI and AW, then we can calculate the Q value. Getting this one? First, what you have to calculate? First, we have to calculate HW. It is BM. Is that to calculate AI here? AI we can calculate this one. Core F factor AC is equal to AI by D square, correct? To D square. AC how much given? 0.56 given. Then D square is diameter of circumscribing circle is given. 0.14 square will get the answer. How much we will get? Can you tell me the answer? How much it is? Calculating or not? You have to calculate. Don't sit blindly. How much it is? calculate that, you will get answer how much? 0.0109 meter square, because it is the area. So we'll get answer in meter square, 0.0109 meter square. Like this, we have to calculate this one. Next thing, AI is calculated. Next, how to calculate AW? AW we have to calculate. AW. What is that AW? AW nothing but it is the height of window into width of window. It is nothing but height of window into width of window. Height of window is given. Next, what you have to calculate? Width we have to calculate. How to calculate that? Here. So it is the diameter of circumscribing circle. Distance is given. Distance capital D is given. Then it is the small d by 2 it is. How much it is? It is d by 2. So it is d by 2. What about this one? This gap is nothing but WW. Correct? Yes or no? It is the core. It is just like this one. It is the WW. So what is WW now? WW
Capital D minus D.
is equal. So capital D is includes what? Capital D includes WW plus 2.06 meter. So it is the WW, correct? So this is the WW value. Substitute here. So AW will be equal to HW how much? 0.24 into small capital D minus small d. So 0.24 understand the things. So now what we have done? So we have calculated the AW value. We have calculated the AI value. Using this core area factor, AI is calculated. Using this height of window and core dimensions, we have calculated the AW. So what is left out now? Left out part is this one. KVA rating we have to calculate. Yes. How to calculate that? Now output equation is equal to, what is the formula for that? So output Q is equal to 3.33 frequency BM AI AW KW delta 10 to the power of minus 3. So now substitute the value 3.33. Frequency how much given? 50 Hertz given. BM value 1.25 given. AI is calculated. How much it is? 0.0109. AW is calculated 0.0144. KW is 0.25. Next, now this we have to substitute. So value given is in terms of mm square, but we have to substitute in meter square. How to substitute that? In last problem I have discussed this one. So convert that 2.5 delta into 10 to the power of plus 6. It will become square. How does it will be plus 6 here? Explain again. So meter ampere per mm square. So it is 2.5 it is in millimeter square, right? So millimeters, it is per ampere per millimeter square. It will come in denominator. 10 to the power of millimeter square means 10 to the power of minus 3 whole square. So in denominator, I am getting that. Now it is ampere per meter square. So now it will be 2.5. 2 minus 3 into 6 minus 6. If you take in numerator, it will be plus 6 ampere per mm square. This much you have to substitute here. 2.5 10 to the power of plus 6. Now it is in the meter square, and 10 to the power of minus 3. Don't leave this one. So substitute all the things. You will get the answer. Can anyone calculate this one and tell me the answer? Can anyone calculate and tell me the answer? So answer will be 16.45. Right? Transformer we are measuring in terms of what? kVA. So answer is in kVA, 16.45 kVA. This is the answer. So like this we have to calculate. So before going to that, what we have to make? First have to list out the data. Calculation we have to make. So what is the output answer we have to get? So that is the things we have to understand before going to the problem part. Like this, we have to do the problem. Any doubt here? Any doubt? Okay, is correct. Okay. Don't have any doubt? So you understand the things, and even I will put the video also. And if you have any doubt regarding this one, just again you have to ask me. I will discuss the problem again and again. Okay, you will be perfect in that. Okay. So don't sit. Will come to know whether you have understanding or not. Okay. Don't sit. Mom, you have to listen. You have to listen, and you have to react to my. Shall I go for next problem? Lakshmana.
Yes, sir.
Shall I go for next problem?
Yes, sir.
So, have you understood previous problem? So already you know this one. Again, I will repeat the things, basic parameters. Okay. Okay. So have you heard the word star connection, delta connection? Star connection, delta connection.
Yes, sir.
So star, it is the delta connection. It is the star connection. So you can say, yes, we are symbolizing like this. It is the delta connection. It is the star connection. Now we can study the relation between voltage and current. Voltage, phase voltage and line voltage. Relation between voltages and relation between currents. In case of phase and line. In terms of delta, in terms of star. Yes, in case of delta connection, relation between phase and line voltage is like this. In case of delta, what happens? Phase voltage is equal to what? voltage is equal
L
to
by 2 3.
line voltage. In case of delta connection, phase voltage is equal to line voltage. Yes, what about current? It is the IL by root 3. It is IL by root 3, correct. In case of star connection, so V phase is equal to VL by root 3 and current are equal. Phase current is equal to line current in case of star connection. In case of delta connection, voltages are equal. In case of star connection, currents are equal. V phase equal to VL. I phase equal to IL by root 3. In case of star, V phase equal to VL by root 3. I phase equal to IL by this one. Getting this one? This is one part. This is one part. Next part is the HV and LV. What is meaning is that high voltage winding and low voltage winding, HV winding and LV winding. So now, for example, I will give, for example, 6600 bar 440 volt, which is HV, which is LV here. This is HV side, right? High voltage. High HV means what? High voltage. So 6600 voltage HV side. This is the LV side. So it is the HV side. It is the LV side. So we can say it is VHV. We can write it as VHV. Voltage at high voltage side. You can write this one voltage at low voltage side. VHV and VLV. And if there are number of turns on high voltage side, it is THV. This is like a TLV, right? This is the high voltage side, low voltage side. It is, you can say it is HV side, it is LV side. VHV, if voltage at high voltage side, we can calling it as VHV. Voltage at low voltage side, VLV. Number of turns on high voltage side, THV. Number of turns on low voltage side, TLV. So like this, we are naming all these things. You have to remember that these are the namings we have to use in case of solving the problem. Next, in case of, we have two types of transformer, right? Step down and step up. Step down transformer. So here we have primary winding and secondary winding, right? In case of step down transformer, we have primary winding and secondary winding, correct? We have primary and secondary. In all transformer, we have primary and secondary, which is HV, which is LV. Can anyone tell me this one? In case of step down transformer, we have two windings. One is primary winding, another is the secondary winding. Among these two, which is HV, which is LV? Who will tell this one?
Primary high voltage, sir. Secondary low voltage.
Primary is high voltage, secondary low voltage. Correct. In case of step down, V1 is greater than V2. V1 voltage is more than V2. That's why primary is HV, secondary is LV. Correct. Exactly correct. Whatever you understood, that is correct thing. Next, in case of step up transformer, in case of step up, so V1 is less than V2. So again, we have primary winding and secondary winding, right? Which is primary, which is secondary?
Primary LV, sir. Secondary HV.
V1 is less than V2. This is LV, this is HV. Correct. This you have to understand first. In case of stepped up, we have primary side is LV. In case of step down, primary side is HV. That we have to understand. In problem, they will give this value. They will give this value. Like this value they will give. It is 6600 bar 440. So you have to understand which is HV, which is LV, which is VHV and which is VLV. You have to understand based on that. So understanding this one. So like this one you remember, this complete part you remember. Basic parameter, relation between phase and line in case of delta, relation between phase and line in case of star. This is important. And next thing is that this HV and LV, HV and LV. Now we have to calculate this one. How to calculate the HV here? Just two formulas we have. One is the THV by TLV is equal to VHV by VLV. Just like a T2 by T1 is equal to V2 by V1. Just like a T2 by T1 is equal to V2 by V1. So what is that THV now? THV is equal to VHV by VLV into TLV. This formula is important. So somewhere you write in your notes this one. So TLV is equal to, so if they ask to calculate TLV, number of turns in high voltage, you calculate like this. Use these voltages and calculate the LV. VHV by VLV into TLV. This much you have to calculate. Then how to calculate TLV? If I don't know THV value, I don't know all these things. I don't know VHV value, I don't know THV value. Then how to calculate this TLV? We can calculate if EMF per turn is available. So we can write like this, VLB by ET. While solving the output equation, we have got the equation, right? So EMF per turn is equal to what? VP by TP. Like this. So it is TLV is equal to VLV by ET. These two formula. This is one, this one, and this one. These two formulas are important. THV calculation, TLV calculation, and these relations. And these relations. 1, 2, 3, 4, 5, 6. Total 6 formulas are important. I will write again here. So THV is equal to VHV by VLV into TLV. Next TLV is equal to VLV by EMF per turn. Then delta star connection, this relation. V phase equal to V line. I phase is equal to I line by root 3. So V phase is equal to VL by root 3. I phase is equal to IL in case of star. These 6 formulas are important to solve the next problem. Yes, I will tell you next problem now. Okay, these are the formula. So using this, you calculate one thing. Just I will give the small example I will give. Yes. So what is the given is that it is the 3-phase motor. 3-phase transformer it is. And delta bar star type transformer is given. Rating is given. How much Q value is given? 300 kVA is given. Next, voltage is given. How much? 6600 by 440 volt is given. 50 hertz given. Delta value given 2.5 ampere per mm square. Then ET value given 8.5 volt. So what are things we have to calculate? Calculate IP, IS, AP, AS, TP, TS. What are these things? Primary current, secondary current. Primary conductor area, secondary conductor area. Primary number of turns, secondary number of turns. These things we have to calculate. How to calculate these things? This much you have understood up to this one. Shall I continue? Akshata? Shall I continue?
Yes,
This
sir.
much I think understanding all these things.
Yes, sir.
Okay. So these are the given data. What are the given data? Q value given, voltage is given, frequency is given, delta star is given, and these things are given. What we have to calculate? First calculate the IP value. How to calculate IP value? We can calculate IP value here like this. So using this Q. So first Q is equal to what? In case of primary side for a three phase, 3 Vp Ip 10 to the power of minus 3. This equation we have used in case of output equation derivation. Recall that in case of output equation derivation, we have used this data. Now, which is unknown thing here? IP is the unknown thing. Q is equal to 3. In terms of phase value, I am calculating. It is the V phase, I phase, 10 to the power of minus 3. So now which is unknown thing? I phase is the unknown thing. Just take outside. I phase is equal to Q divided by 3 P phase 10 to the power of minus 3. How much Q value is given? 300 is given. It is in terms of kVA only. Don't write 10 to the power of 3 again. It is just write 300. That's it. Divided by 3. VPH how much? VPH, this is the primary. This is the secondary, correct? It is primary. So 6600 bar for 40 volt. It is primary side. It is the secondary side. It is the HV side. It is LV side. Understanding this one? This is delta side. This is star. Like this. Understand? Primary, secondary. This is HV, LV. It is delta star. Getting? Next, in case of phase voltage, delta side, sorry, in case of primary side, delta connection, what about V phase? V phase equal to VL. What is meaning is that whatever data they are giving here, these data are nothing but line values. Remember this one. In problem, whatever data they are giving to give, that values are line values. Means what? It is the VL value. These two are the VL values, line values. Maybe primary or secondary, but these two are the line values. These are the line values, line values. Now we are substituting in terms of phase value. In case of delta, phase value equal to line value. So no need to convert, nothing is required. Directly substitute the value 6600 into 10 to the power of minus 3. How much it is? So we will get 15.15 ampere. 15.15 ampere. Like this, we have to calculate the current value. Next, secondary value. IS value we have to calculate, right? phase we have calculated. I phase we have calculated now. How did? So I will take new page. So IS value is equal to, again, what is the formula for that? 2 is equal to 3 Vs Is 10 to the power of minus 3. I need to calculate in terms of phase. V phase, I phase 10 to the power of, sorry, I phase of secondary it is. It is of secondary values. These are secondary values. So it is I phase, how much it is? I phase of secondary. Q divided by 3 V phase of secondary voltage into 10 to the power of minus 3. How much Q is? 300 is given. Q is 300 given. V is equal to 6600 by 440 volt. It is the delta. It is star. It is the primary. It is secondary. So it is these are line values. These are the line values. Substitute here. It is V. So secondary line, this is the secondary voltage, right? Line value it is. But in case of this star connection, in case of star connection, V phase is equal to what? VL by root 3. Yes, it is 440 divided by root 3. So phase value is equal to VL by root 3. Where it is? In case of star connected secondary, it is star connected secondary into 10 to the power of minus 3. So if you calculate all the things, you will get answer. How much you are getting? IS value, can anyone calculate it? So calculate that and get the answer. So it is the IS value, phase value. IS secondary current, but it is a phase value. Phase value. Even we can convert that. So it is a secondary value, it is a phase value, but in case of star, both are same. So line current and phase current both are same. So directly you get the answer. It is ampere. It is ampere. Getting this one? Next thing. What is the next thing? Area calculation. AP and AS calculation. How to calculate AP and AS here? So what is that current density? Current density is equal to what? It is the IP by AP, correct? This is the formula, sorry. IP by AP. So in case of secondary, delta is equal to IS by ES. Then calculate AP here. AP nothing but what? IP by delta. IP is just you have calculated 15.15. Delta is how much given? 2.5. So 2.5 is given. So directly you can calculate the answer. 2.5, it is in terms of what it is? 10 to the power of 6. So you will get the answer in meter square by delta. Somehow answer will calculate, substitute the value, answer in like this. Next, what you have to calculate? TP and TS. TP nothing but what? THV. TS nothing but what? TLV, because this is the 6600 bar 440. It is 6600 bar 440. So it is the high voltage term. It is a low voltage term. What is the formula for low voltage term? TLV is equal to what? TLV is equal to VLV divided by ET. ET value is given, right? 8.5. ET value is given 8.5 ampere. Sorry, volt. ET value is given. So use that, calculate. That's it. It is the 440. It is the 440 by root 3 it is, because it is in the line value. In case of here, we have to substitute the phase value. We have to substitute the phase value. So it is the star side. That's why it is by root 3. It is 8.5. If you get, you'll get the 29.89 turns. So THV you can calculate. It is the VHV by VLV into TLV. Just substitute all the data. THV is how much? 6,600 by 440 by root 3. Here we are not calculating by y root 3 because it is delta side. In case of delta, V phase is equal to V line. Directly you can substitute that. But in case of VLV side, the star connected, we have to convert that. We have to convert means what? Dividing by root 3 we have to make. It is 29.89. So at last we will get some value, almost 776 number of turns you will make it. So THV we will get. So like this we have to calculate the data. What are things we have calculated? IP is calculated, IS is calculated, AP, AS, TLV and THV. These are the things we have calculated. Just I have given an example here. So like this in problem we have to solve all these things. We have to use this problem, and like this we have to solve the problem. Understanding this one? So can I give one problem here as a homework? So in homework I will explain that homework. We'll do that. You make it as classwork and submit it in the Google Classroom. Okay. So I will give the one problem now. I will explain how to calculate that and solve this, and you put it in my Google Classroom. Okay. 1 second. You can see the problem here. You note down this problem. If you have any doubt in between, you can ask me. Don't sit mum him. Just we shall discuss the things. Okay. It's not a one way. It should be two-way. Not be one way. It should be two-way. Then only we'll come to know you have understood or not. Otherwise, it is difficult to tell you. Okay. So you have to always interact with us. So even if it is not now, yes. Is it visible now? Yes. So you take a just screenshot of it. I'll explain the things. Estimate the main dimensions, conductor area, number of turns, and primary and secondary. This much we have to calculate. Data is given. Q is given. Data is given. The voltage is given. Frequency is given. And diameter of circumscribing circle is given. And leg spacing is given. So EMF per turn, ET. I will explain what are the given data. You solve in your own. Okay. So what we have given? What we have to calculate? So Q value is given. This is the Q value. So it is the 6,600 by, it is the voltage is given. Voltage is given 6,600 by 440 volt given. The delta side, it is the star side. Delta side and star side. And 300 is, what is that 300? 300 is nothing but it is the Q value is given. It is the Q value given. Next, what you have given? Frequency is given. Then what about this one? It is the diameter D. It is the diameter D. Diameter D it is. Next is that leg spacing is given. What is the meaning of leg spacing is that? So it is the core. It is the core. It is the core, and these two are legs. It is the first leg. It is the second leg. Distance between these two. Distance between two legs nothing but what? It is the WW. But ET is given, EMF pattern ET is given, current density delta is given, window space factor is given, stacking factor is given. It is not useful in your problem. Okay, just they have given, don't use that. This much is given. What we have to calculate? Conductor area, means what? AP and AS we have to calculate. Number of turns in primary and secondary. TP and TS we have to calculate. For calculation of AP and AS, we need IP and IS. Correct? So APS, TPTS, IPAIS. Just we have seen all the things, how to calculate all the things. This much we have to calculate. Along with that, main dimensions we have to calculate. Main dimensions means what? AW and AC. AW nothing but height of window we have to calculate, width of window we have to calculate. HW, WW, WW is already given. So calculate HW, you will get the AW. And AC we can calculate. AC we can calculate with the help of given data. AC is equal to what? AI by D square. Diameter is given. AI you calculate. AC we can calculate. These are the dimensions. Dimensions nothing but what? HW, WW, AW, AC. This much. After that, in window area, TP, TS, IP, IS, all things you have to calculate. So you try this one. If you have got it, that is a good thing. Otherwise, again I will discuss. Okay. So you solve this one and put it in my Google Classroom after completion of your next class. So within 2 o'clock you submit the answer. Within 2 o'clock you submit the answer. Okay, I think it is understanding. I think it is understood to you. If you have any difficulty, you can ask me afterwards. Okay. We shall leave the class now. I think you have next class. Okay. Thank you.